for sure, everyone always thinks that they live at the most exciting time ever.
Right. And you think it's like the most prolific and the most important and the most complicated.
But we for sure do.
Of course, we for sure do. It's this moment right now, unquestionably. It's a blockade in ancient Rome. Come on.
Hey everybody, it's the Zengineering Podcast. I'm Adam.
I'm Brian.
Do I usually say it's a Zengineering Podcast?
I don't know.
Weird.
My brain has delegated that to some lower function, so.
There you go. Welcome back for another episode. Thanks for joining us. And thanks, as always, to our backers on Patreon who throw us $1 an episode to help keep this thing going. What are we talking about this week?
So we're doing a second episode on quadcopters, and generally like unmanned aerial vehicles. But we're going to dive into the actual like technologies, like how they function, how they work, what's on them, what allows them to measure their environments and move around and do stuff.
First, what do we have of note in science news?
Oh, good question. You caught me unprepared with a specific.
It doesn't matter because Stephen Hawking died, and so we have to talk about that.
All right. Did you hear Stephen Hawking passed away?
I heard somebody else talking about an interview with him where somebody asked him if you could, I think it was Neil deGrasse Tyson asked him, if you could ask Newton anything, what would it be? And the question that he wanted to ask him was like, he wanted to lead Newton one step further than he had gotten. It was like, I want to ask Newton about what, in the context of his exploration, he would have explored next, basically. Like, he didn't care to be like, yo, Newton, here's all the shit we know. He just wanted to have a conversation where he's like, well, what do you think about if this happens? Like, he wanted to test his mind, not have a conversation about quantum physics with this guy who's so far down the chain it would just blow his fucking mind.
Man, what an interesting, it would be such a neat experience to bring someone who like pioneered something like that into the future, to just have them sit in on like a college course teaching the thing that they invented. Can you imagine?
I think an important part of being good at that mode of inquiry is to realize that like 50 years from now, I'm going to live in a world where most of it is going to be a thing like, well, couldn't have seen that coming.
For sure.
But I think acknowledging that is part of it, right? Like, he just wanted to have a scientist conversation with Newton. He wasn't like, I want to get this great thinker's thoughts on blah, blah, blah. Like, a great thinker's thoughts are only good for their period in time. And that goes back to what you were saying before about like...
Well, they're like cutting edge scientific thoughts are only good. I would imagine almost every other conversation that you engage in day to day, they're probably just right there with you, right?
Right.
What's it like to have a kid? How frustrating it is to get up every morning for work. Right?
What it's like to have the gout but be pushing through. You can literally...
Were you frustrated when you realized you had to stop drinking in your 30s?
Seneca had some kind of like tuberculosis or like asthma or something that he occasionally refers to. And it's why it's interesting reading some of those. The presentation of a lot of ancient philosophy is letters back and forth, usually between like an academic and a dignitary of some sort. So if you go read a bunch of Seneca, it's just letters that he sent to emperors and stuff. And so he talks about things where he's just like, I've gone up to live in the mountains for a time because the cough has gotten the best of me. Like, he's referring to things that we can identify now, I think, as medical conditions, where he's just like, I went to a drier climate because coughing overtook me. And then he writes a letter about pushing through that discomfort to try to continue his thinking about stuff, doing things.
Totally.
It's interesting.
I was just looking at the pictures of Data from Star Trek playing poker with Isaac Newton, Albert Einstein, and Stephen Hawking. And it never occurred to me until just this moment, looking at these pictures and seeing actual behind the scenes shots, that Stephen Hawking was playing himself in the episodes.
Yeah.
Obviously, Newton and Einstein weren't, but that's cool.
Yeah, weird, right?
Yeah,
like we
super
also
weird.
are creating a world where we have like you can't go watch videos of Newton doing stuff, but you could go down a day-long YouTube rabbit hole of Stephen Hawking jokes and pop culture. He was on The Simpsons a couple of times.
A bunch. I saw him speak live at a TED event I was at. He was the surprise guest speaker. He cruised in. Everyone, there was like hints that he was going to be the guest. And then like in the...
Was this the Feynman thing?
Yeah, this was a Richard Feynman based physics TED Talks at Caltech. And
just that.
He's the appropriate guest there. I mean, where else is Stephen Hawking going to cruise in? But he literally cruised in the middle of it as like special guest, cruises down the mid aisle, pops up on stage. He told a joke, and then he's like, "I gotta go," and then he took off. It was baller. It was really baller.
That's more or less what he did on The Simpsons. Like he made fun of Lisa for something, for disappointing him, and then he sprouted a helicopter blade out of his wheelchair and flew away. I certainly don't feel as sad about it as I feel about like Tom Petty. But also, I wonder if part of that with Hawking is, given his condition, we were always kind of like, well, that's going to happen soon. Like part of his narrative has always been, oh, he's continuing to degenerate.
Yeah, that's an interesting question. It also, his personality doesn't like day to day affect me, and although maybe his like mental creations and discoveries ultimately affect the world in a grander way, Tom Petty has had like an unquestionable weight added to the world in prolific emotional creative exchanges, right? So,
well, but that's part of this whole conversation that I think pisses scientists off so much. The stuff that he's important for results in the technology that makes possible what people with the magnitude that you just described of like Tom Petty, it wouldn't exist if we didn't have people like Hawking working on problems.
Like the fucking electric guitar.
How do atoms move around in the world?
Good luck.
The electric guitar wouldn't exist without. Right.
So it's, you bring up a good point, and I think it's because, or I also get frustrated by sometimes, and I just fell victim to it a little bit, right? Because I think stars are really easy to attribute the success to, right? It's like, well, Tom Petty did it. Tom Petty didn't do shit, right? And he sits on top of a billion musicians.
Stars not burning balls of gas. You mean stars like celebrities.
Right. He sits on top of an infrastructure, a music infrastructure, and a lineage of poets and thousands of years of writing and creativity and musicians and bards, and like, he didn't do anything. He just happened to be a kid who wrote some songs at the right time, and they like fit in. So I don't know.
Well, regardless, it's cooler.
It's way fucking cooler, for sure. On a global scale, it's cooler.
Right.
I would. Oh man, that's a toss up. I mean, we've tried aggressively to be cool our whole lives too. So like, I can picture myself playing a concert. Whereas I think a lot of people who have also spent time like doing research in a lab probably can't picture themselves playing in a concert as easily as I can imagine myself being a successful musician, which does not mean that I should be in any way. But like,
do they picture themselves giving TED Talks?
Yeah, probably. They can probably imagine themselves at a TED Talk more easily than I can.
The thing about reading ancient philosophy is makes you realize that there's always been a slot in society for pop culture relevant academics. They just were philosophers. Then for a long time, they were priests, and then, or monks or something like that for a long time. And now they're scientists. Mm-hmm. Slowly they're becoming, I mean, not even fucking slowly. Everyone knows who Jeff Bezos is. Elon Musk, right?
Elon Musk is certainly an anomaly.
So I expected that Stephen Hawking conversation to kind of go off the rails, but
great. Back to quadcopters.
Back to quadcopters. Okay, so my first question, if you're going to chase the technology of a quadcopter, is like, what's the critical piece that made it so that it was like, oh hey, quadcopter?
I think,
and I'm going to keep painting you and take it all the way back to like, how do you start to solve the problem if this thing needs to be in the air? We kind of talked about that last time, like philosophically, but technologically.
Yeah, that's fair. So,
right? What's a propeller do?
Yeah, okay, fair. So the propeller, think of it just as a bunch of little wings that are...
The only thing that makes a drone not a remote controlled car is the propeller.
Right. Yeah, I mean, think of helicopter propellers as basically airplane wings that have their own source of propulsion. So they spin around like a wing, create lift, and then the little airplane can lift off the ground. Whereas an actual airplane that has two stationary wings has to produce its own thrust to create lift from the wing. But a helicopter, it spins its little wings, and by the physics of lift, the helicopter magically rises into the air.
And we talked about a lot of the sort of trade-offs in terms of the idea of these things, I think, in the last episode. So my thing is like, let's just chase it. Okay, what's driving the propeller on a drone?
You've got little electric motors. Oh, they're gas-powered drones too, I think, right? So yeah. Little IC engines, maybe?
They could be gas-powered, but it's certainly a messier way to do it. It's not the reason the ability to gas-power this apparatus is not the reason that I will ever use one.
Drones are prolific. I mean, my original answer to your question my answer to your original question here was affordable miniaturization of all this stuff, right? Like we're able to mass produce little injection molded plastic propellers. We're able to produce plastic propellers that are pennies, right? We're able to produce tiny electric motors that are super efficient and powerful for $5, $10, $20. And so on a drone, on a quadcopter drone, the sound that you hear, they sound like a hive of bees coming to get you, right? It's kind of a scary noise to see how powerful something so small is, but you're getting both the sound of like that little plastic propeller whipping around so quickly, and you're getting a little bit of a droning sound from these little electric motors running. And that's what the power from the battery on a drone is doing, right? It's sending out electricity. Which is ironic. For the most part.
Which is ironic because the term drone, I don't tend to think of it because of that noise. I think of it because it means that they're not, like in my head, drone is a mindless automaton. Right?
What does that word even mean? Define drone. Define drone for me. Make a continuous low humming sound as a verb or noun, a low continuous, a male bee in a colony of social bees, which does no work but can fertilize a queen.
There you go.
What are UAVs fertilizing?
What are democracy?
Freedom?
Different conversation. So we have so motors. So there's this mechanical problem. We needed to spin this propeller to make it go. So it will generate lift. Part of this is miniaturization. We managed to get that small enough that you can put it in a really small space. That involves using motors over engines, which is the thing that we covered, I think, in like our third or fourth episode, the difference between motors and engines.
Yeah, we did. We did an episode on
engines. But immediately you're like, okay, so controlling that motor becomes an important thing. And so I remember you explaining to me once what a flight controller chip was and exactly what's going on that chip.
Yeah, it's interesting. There's like this little layer of stuff between your control and the motors. So, I mean, everyone knows you fly a drone or you control a remote control car or even like military UAV drones, right? People are flying them with radio controlled joysticks or I think even Xbox controllers are used by the military to control some of this stuff. But your input goes into what you mentioned, a flight control board, which has a whole bunch of sensors on it. And those sensors kind of describe to the drone or the vehicle where it is in space, how fast it's moving, whether or not it's balanced, whether it's flying in one direction or not. And then from that, it makes decisions as to which of the motors to speed up or slow down. And that affects how it moves, right? Is it just trying to hover? Is it trying to go in a particular direction? Is it trying to spin around in a circle? Is it trying to change its like orientation in space? Does it want to go up and down, right? There's a lot of different movement. And how do you
And so
achieve that?
sensor wise, there's a good chunk of this conversation that is the same as our conversation about virtual reality, where we talk about how the system knows where you are in space relative to this world it's trying to create in VR. But these are all solutions we also had to solve for cell phones, like so that you can get signal to this like single most important device in most people's lives these days, their smartphone. But on some scale, you're using literally the same mechanical technological tools
I would
solve a problem of, okay, this, you can only control it so much from a remote as a human. And then there are these things that dynamically need to be compensated for if you want it to keep a thing in the air. All of the logic to do that is offloaded to a chip that lives on the drone. And you can program that to manipulate, everything in the system, right? So let's talk about the sensors. Like, how does it know where it is in space, right? Because it needs like a altimeter. It needs to know that it's not on the ground, right?
Flying vehicle, right? So it needs to know where it is in the sky, height wise,
and then it needs to know how it's oriented,
right?
But unlike VR, you can't just put sensors in the room that fire at it, and then it goes, okay, I know where I am. I mean, that's kind of what GPS is. But it only works to a certain, there's a latency on GPS, right? Like you only get down to like 100 meters. It's why sometimes it's like, oh, you're on the wrong road.
There's a resolution, and it's interesting. It's depending on how you use it and where you use it and the weather and everything, all of that can change. And also who you are, right? Like we don't have access to GPS that's as clear as the military, I don't believe, but nor did we have the GPS we have now until like the interesting GPS story, actually. When Bill Clinton was president, I believe that there was a missing airliner that crashed and disappeared, right? And we were trying to rescue anyone who was still alive from the airliner. And the U.S. military had GPS technology, which the public, the world, was able to use on a really low, like a very low resolution scale, like you were saying, miles or maybe even hundreds of miles GPS to locate stuff. And I'm sure this was kind of like they were planning this anyway, but he allowed access to higher resolution GPS that the United States military had been using for a long time, and that led to all of the GPS capabilities that the planet has now. So everything that we do that uses GPS, our cell phones globally, are for the most part running on U.S. military GPS technology that the U.S. has made available. It's a series of like 30 satellites that we built and maintained for our military that now are a global good, which is a neat story, right? Because it's such a prolific and obvious application of something that was built for military that has become world changing for the whole planet, right?
I think you see a lot of that tech in places like the space program because it takes giant cooperation and organization to apply the scientific method at certain levels of granularity. But you see the same behavior now, even in blockchain projects. But like nerds still work that way, where research gets done, then they go, oh yeah, okay, this is a good application. But not dying is the primary motivation behind everything. So of course it starts with the military. They throw money and people at the problem until it gets down to a certain level of accessibility. At least that's kind of the idea. But part of what's gotten weird lately is blockchain diffusing that. Anyway, it's not a blockchain conversation. So if you're a drone in space, you need to know. So all we've done is offloaded the sensing of this information to increasingly distributed methods. by proliferating technology that can just handle the problem on board. And we need it for cell phones, so it's really cheap to make at this point. So you can make a drone that uses GPS to know where it is relative to the granularity that can give you. It uses your Wi-Fi signal to do the same, triangulate you in space. It has a compass on there. They call it a magnetometer, but that uses the Earth's gravitational force to know which way you're facing, all to a degree of granularity. In the VR episode, we chase where that granularity goes from like where we are here. But for drones, that's really all you need within a certain amount of space, unless you want to not bump into things. But all of that logic is offloaded to this chip. And so so you're able to write a program that just goes, okay, where am I in space based on all these sensors? And here's how I'll compensate with force to the rotors. And now a human can control that thing from a remote control, even though all of this way more complicated than we could, just think about on our own is happening off board on the drone.
Yeah,
and in that sense, it's a drone because it has this autonomous set of processes that we've offloaded to a chip that are just being controlled by someone on the ground who, if you say go up and your drone doesn't go up, a lot of people just go, oh, fuck. And then they call tech support. They don't know they can't manipulate the logic on the board to fix a thing.
Yeah, diving into how flight control boards work on quadcopters was really interesting. I mean, realizing I was familiar with all of these sensors. I'd used them in robotic design when I was working as an actual manufacturing engineer. But to kind of have them come together and solve the problem of where this little creature is in 3D space and where it's looking and how it's oriented and how the software should run to affect its motors, which are really its only means of propelling itself and moving around and orienting itself. It's really interesting. It's exactly what you were trying to describe there. It's a little being, it's a little thing that has intelligence about itself, and it's trying to figure out what its place in the world is, right? So the flight control board is this. It's a little electronic board, like people who've ever taken something apart that has a little like green electronic board inside. They're not all green because people are hip to electronics now, so we paint them other colors, but traditionally they've been green. The board has this set of little sensors on board, little machines. They're often called MEMS devices, which I forget what the exact acronym is, but they're micro machines. They're very, very tiny machines that are instead of something that you could pick up and look at how it works, it's like machined into silicon, like we make microchips out of. And so you have the most very basic stuff that you need to just have a drone and fly it. You need a set of accelerometers and you need a magnetometer. And what those do together is allow the drone to know. Am I going?
No, do it.
Too weird.
Perfect.
So you've got kind of a fundamental positioning issue with your drone that until you really start to think about how it knows what's going on, that it's really complicated. And this is an interesting philosophical space for the human body too, when you dive deeper into like how your brain knows what its hand is and where its hand is and stuff. Extremely, extremely complicated to do the kind of things that we do with our bodies with machines. And I really got exposed to that building robots for manufacturing when I was younger. But so the accelerometer, I think, is kind of at the heart of it, knowing what's going on. It's the first thing, and there are these little devices that I think accelerometers. The simplest ones are just built with strain gauges. They're like, so imagine holding.
It's a sensor that is just constantly telling the device, "Have I jiggled lately?"
Right. It's essentially a piece of metal that when you like move it, it changes shape a little bit. And that change of shape changes the way electricity flows through it. And so you can measure consistently, like, how is it moving and how is it changing shape? And so what an accelerometer specifically is designed to do is to kind of detect the force of gravity. And so you end up in something like a drone, because it's moving around in 3D space as opposed to like driving on the flat ground. You put 3 accelerometers in there and you put them at right angles to each other. And in doing so, you're able to detect the force of gravity in 3 dimensions. So in 3-dimensional space, all of a sudden, no matter how you orient your drone, those 3 little accelerometers, they're feeling gravity, and the little piece of metal or the little piece of material is bending a little bit differently based on how it's oriented. And in doing so, you send some electricity through it and you physically measure the force of gravity, and you can kind of calculate how is the drone oriented? Is it sitting flat? Is it turning? Is it upside down? And it's really neat, because that those weird little tiny devices all of a sudden give your drone it answers
a nervous system.
Yeah, right. You're building
conceptually. You just described a nervous system,
which
right? Like our body is doing it on a scale we just can't understand all day.
Right, we have the same sort of sensors in our ears, right? That's where our sense of balance comes from, I think, right? I think it's little bones and forces of gravity pulling, and it's why you get so it's why you feel so uneasy, and why people get what we consider like feeling sick to your stomach on a roller coaster ride, because your senses, you don't have that constant sense of gravity of where your body is and how it's oriented in space anymore. And so your body says, whoa, what the hell is going on? I've lost this major sense that we don't think of day to day as sense, because we're not typically concerned with like how our body's oriented. We get it. It's just part of life. It's different than like touching something hot and thinking I'm about to get burned. Like we get that as a sense of touch and sense of smell, but sense of balance is just so ingrained in how we exist once you're past like the age of 5 that you just kind of forget about it.
And so what you're talking about at that point is again, this came up in the VR episode, but you hit a point where to increase the granularity of the knowledge you have about your surroundings, which is what your nervous system is doing constantly, you start needing sensors like eyes that actually look out into the world and pick stuff up.
Yeah,
the thing we can do
feedback
with VR right now is shoot lasers at you and pick up information, and that's an effective way to like take you and put you somewhere else. But to solve that problem without the external things firing at you, you just start having to use sensors that essentially look out in the world, right? Like, so if you want a drone that automatically doesn't run into trees, which is a pretty valuable problem to solve, you just use cameras, right? Like it has 24 cameras on it. It's looking out and it's analyzing the image and it's responding to what's going on there.
Which is unfair to say that we're not shooting stuff at it, right? You can't sense things without other stuff, right? So just talking about
just using the sun stuff instead of
right. It's using lasers
or whatever, or radio waves that we have just dispersed into the world to use. As
none of the features. That's what's so interesting about this, right? I was going to say that the accelerometers are kind of an internal sensor, because in reality, the accelerometers don't tell the drone much about its actual place in the world. It just tells itself how it's oriented relative to the center of the planet, the center of gravity of the planet. But it's using gravitation, right? It's using this thing that exists in the universe that I don't even know if we can really describe what it is very well, but it's a thing that we can measure. And
when you say we, you mean the scientific community, not like me and you.
Well, shit, you and me, right? I mean, I had this.
You really don't know what's going on with gravity.
I got a flight control board and I plugged it into my computer and I could read gravity, right? I could see what it was measuring
relative to that drone, right? So when you say this stuff has been offloaded, like to build a drone now, you don't even have to. It's just all hard coded on a chip that you can buy for $20. Right now on Amazon.
Yeah, I think
that is surprisingly powerful.
I think 6 years ago.
What did it cost you to build a drone 6 years ago?
I think I spent like $350 maybe. And it wasn't necessarily the drone parts that even cost that much. I mean, I probably went through a couple bodies and I had a handful of parts. I was building a drone back before you could just go buy a commercial drone. So I was kind of sourcing parts from blog posts and foreign vendors and stuff to get these things I needed. And that seemed relatively cheap at the time. The actual board that controlled it, I'm pretty sure was like $22. And then the software was all open source, right? So you could actually go download the software and edit it and start doing your own projects on it.
Our buddy, friend of the podcast, runs a farm. I won't drop him by name. I don't think he would appreciate it. But I got to go watch them do an aerial survey via drone of a field that they're assessing to put a vineyard in. And it was crazy. The dude set up like survey markers at the corners. He drove around with this thing that took a really detailed reading of where it was in space, and it set out the corners for where a drone would scan and take really high resolution photos every few feet so that they could mesh together perfectly within a square. So watching this field survey was like, the guy showed up in a truck, he drove around with this thing, marked the corners, put a stake in where the mark was, and we sat there and shot the shit for 45 minutes while a commercial drone carrying a better than average camera just went zzz, zzz, like a Roomba going across like a kitchen floor. And then they delivered this remarkable analysis of like how fluid will flow on the hill in the field. And they did this topographical analysis from just assessing the photos.
It's wild what can be done with these devices, right? I mean,
and it's because software ate it, right? Like it stops being mechanical.
Well,
past a point.
There's always that analog to digital piece here, which kind of begs the question: is anything analog? Which the answer seems to be no, because there's quanta when you get down low enough. But there's an organic component, and the accelerometers on a drone are like they're an organic sensor, right? On a big level, if you zoomed in, I've used strain gauges that are big that you can see and you like put on things yourself, and it's like a little piece of metal, and you connect two wires to it, and you connect a battery to it, and then you measure the electricity, and from that the software looks at it and says, hey, it's changed, and this is the rate it's changing, and this is what it looks like now, and but you're totally right. Once we have this stuff, and we have billions and billions and billions of these, right? Because all of these sensors that are in a drone are in your cell phone, right? Like you could strap your cell phone on there, and there's actually probably software. I would say almost certainly you can download software on your phone that acts as a flight controller, and you can get an adapter and just put a phone on to build a drone. I don't know why you'd want to do that because the boards are so cheap, but
I think the route generally tends to be use your phone sensors to a point to pre-program it and then let it run for applications that need to be that specific. But I think you could do the same thing that this surveyor was doing just by, taking the phone to a point, saying corner, taking the phone to a point, saying corner, taking a phone to a point. It would decrease the granularity a little bit, but you could compensate by having a better camera pretty easily. You can offload a lot of that logic processing to the phone, right? Like a lot of those commercial drones are sort of controlled in that way via cell phone. Like you either have to plug it into another thing, or you can take the weight. I mean, that's a funny part of the thing with this, right? The lighter you can make the device, the more effectively you can, or efficiently and thus cheaply, cause the thing to do what it's supposed to do. And now we're to the point where you have drones that can just fly around your bedroom pretty competently, just dealing with the latency of a wireless signal because all of the processing is happening on your phone and just being communicated to it wirelessly. Do we need to chase down wireless tech?
I was going to go into a couple more of the sensors that kind of actually put you eventually get like a full image of where the drone is, because the accelerometer.
Do it. There's a point where I lose track of what's on there, right? So, like what else do you need to know to pull this off at the level that I can have a drone deliver me pizzas?
The accelerometers that we talked about that give it like, if you've ever seen like pitch, yaw, and roll, they're like the three orientations of a plane.
It's why you fly a fighter plane with a stick, right? I mean, isn't that essentially?
Yeah, basically.
So you can control all of this 6 degrees of.
You can't. Well, the difference on a plane you can roll it, and you can. I don't remember which one.
Pitch it forward.
You can roll it and you can pitch it forward or backwards, but you can't go up and down. So that would require you to like pull the joystick up or press it down. But you can with a helicopter, which is the orientation, the movement that a drone has. And so with the accelerometer, really just tells the drone how it's oriented with respect to the ground. It doesn't tell it, however, which direction it's pointing. So it kind of tells it like in space, am I upside down? Am I right side up? Am I tilted 45 degrees to the right? It tells it that stuff, but it doesn't tell it like which direction is north. And so to all of a sudden get like a directional component on the planet, you need a second sensor. You need something called a magnetometer. And the magnetometer is reading another one of the wonderful pieces of data that the planet puts out on its own, the magnetic field. And so the magnetometer all of a sudden adds the measurement of what direction am I facing. So now the drone knows, hey, I'm upright, so I'm sitting here hovering. I'm going to turn until I'm facing north. And so all of a sudden it has a little more orientation with respect to the planet. It knows directional how it can go.
And part of these is this is a relative. Every layer of this is a relative reading because you're comparing the thing against how it was either an instant before or how it is relative to these other things. So once you know where you are in space, when you stack on which way you're facing with the fact that you can record it dynamically, now you've just stacked up like, here's where I am on the Earth, but it's still relative to a set of things that you're able to sense.
Well, that's
with eyes, you can go, oh, I'm up over here and this thing's over there. And that's so we've also chased cameras down to this level of everything we talk about in the camera episode happening on that device. Right?
Right.
Everything we talked about in the AI episodes happening on that device.
Yeah. Yeah. Absolutely.
Relative to all of those things.
Absolutely. All this stuff is coming together to make these little toys that you can buy for a couple $100. Which is same reason your cell phone can do so much stuff, right? And the same reason.
How does it talk through altimeters and barometers?
Yeah, so
because you have those on your device now too.
Yeah, so the next component. So now your drone knows the direction it's facing, and it kind of knows how it's oriented. So it's able to level itself out.
It knows where it was before.
Yep.
Relative to all of those.
It knows its previous orientation, and it knows the direction it was facing before. It still doesn't know. It still doesn't know where it is on Earth. Right. So all of those sensors could tell it how it's oriented, but it doesn't know, like, am I in New York or am I in California? Right. It still doesn't have that sense, nor does it know how high it is in the atmosphere. It doesn't know if it's near the ground or if it's 1,000 feet off the ground. So it uses something called an altimeter to measure its altitude, which I'm not super familiar with, like, accuracy here. I think you have to technically reset your altimeter every time. So it probably does this when it's on the ground. When you first turn it on, it tests the atmospheric pressure because that's what it uses to know how high it is. It uses a barometer, and a barometer measures atmospheric pressure. So it literally measures essentially how much atmosphere is above me, how much air, how much water, how much nitrogen, oxygen, carbon dioxide, how much is above me and how much is it pressing down. So kind of like going to the bottom of a bathtub and measuring how much pressure is there from the water. And so when you measure barometric pressure, the pressure of the atmosphere, there's a very strong correlation, at least in our relatively close part of the atmosphere. How high you are, you can calculate based on what the atmospheric pressure is. You just know how much atmosphere is above you. So at the level that people are flying drones, that's pretty accurate. So it measures it while it's on the ground. And then as it's flying, it can say, hey, the pressure reduced a little bit, so I must be up in the air higher. And you program that software in, and then it knows its height. So now it knows, what direction am I looking? How am I oriented? And how high am I in the atmosphere? How high off the ground am I?
We learned a lot, scientifically speaking, in terms of how to measure this stuff by building things like submarines where we paid attention to it underwater. Mm-hmm. It's an interesting idea that you can do things like fly as long as the way that you perceive the medium you're moving through, as like, imagine like a bird probably feels the way that you feel in the ocean because you're buoyant.
Mm-hmm. Totally.
Right? You just float on the thing, right? So birds aren't like, I'm fucking flying. They're probably more like, I'm swimming.
Right. Totally.
Which is an absurd way to think about it. But so like that's how I always sort of conceptualize gases or fluids.
Yeah.
right? So how you conceptualize the sensation of knowing where you are in a pressure system.
Yeah.
And so as you stack all this stuff up, it's all just that stuff exists in a cell phone so that they can beam you signal and you can do the things you do wirelessly.
Yeah, it's really interesting when if you go look up like atmospheric waves or cloud waves and stuff, you can see these large pictures where the atmosphere looks like waves in an ocean. Because it's kind of the same thing. We can't see it really, so it's harder to appreciate. But we're basically lobsters at the bottom of the air ocean, whereas lobsters are at the bottom of the water ocean, right? And so
Right.
we're these little ground dwelling creatures that can't really get up in the sky without drones or hopping on the back of a dragon. But it's there.
This ties right into the current exploration on planets that we have sort of on our list of to-dos. Because that also holds once you get like it's this density layer cake. And once you chase, like physics just exists in this world of densities. And outside of the atmosphere, it's like, okay, here's how the game changes. But we're also pretty adept at this point of like, okay, we're going to go around this planet and we're going to fly out here. And it's like, hey, it worked.
Yeah, it's amazing what we're able to do just based on gravity and the pull of the planet or pull of bodies, planetary bodies pulling you towards them, right? It was the weirdest realization. It still feels weird to me when I think about it, but it makes conceptual sense that like the ocean is there because somebody poured a cup of ocean and it like flowed out to where the ocean would sit, right? Because we're used to pouring fluids like that. But the atmosphere and everything we breathe and interact with is the same way. It is just poured on the planet and just kind of settles in to where it fits, right? It's a little different because it kind of expands and then gravity fights it and it doesn't just escape like air would without gravity, but it's just this fluid layer that settles into valleys. You see it with like clouds coming over mountains and stuff. It's really a spectacular realization. And watching some videos like that and looking at images of stuff like that is really, really neat. Changes your perspective.
Bam.
Yeah, so the drone now knows its orientation, where it's looking, and how high it is, but it doesn't know where it is on the planet, which is an interesting problem for it because it can't really tell where it is. There isn't a sensor we can put on there. You could put like sextants.
GPS only gets you to a certain granularity.
Well, GPS is interesting because GPS doesn't work. We had to build GPS. We can't do GPS with natural energetic resources that are coming off of the planet. We had to put satellites up there that know where they are, and by proxy can tell the drone where it is. So when you throw a GPS, that's when you get to a new level. I didn't have GPS on the drone I built, although I did have some GPS chips I was playing with. But once GPS is on there, that's what like the drone that probably surveyed the farm did. You were probably marking GPS coordinates, and then the drone you just press a button and the drone checks in with GPS and flies around and covers the area. So GPS is kind of that last component, which says
it also comes back to you halfway through to get a new battery.
Did it like install its own battery, or did you have to pop the battery in?
No.
Sucks.
But I did know someone once who was working at a startup that was trying to handle that part of it. The self-talking drones exist; they're just expensive.
You've seen the video of the like Tesla charging station robot that tries to plug itself in,
elephant neck looking thing, and then
I got a lot of shit when it first came out.
Way more menacing.
It looked very menacing. It looked like the tail of a scorpion trying to stab you. But yeah, once you have GPS, you've got these 4 sensors that tell a drone or let a drone know its entire orientation on Earth, right? It knows how it physically is in space. It knows the direction it's looking. It knows how high it is in the atmosphere. And now it has a point on the planet. It can tell if it's in New York. It can tell if it's in LA. Or more specifically, it can tell if it's at the corner of a field of crops or in the middle. And it was really interesting when I first was playing with these drones. It was so interesting to think through all of those components and how complicated it is to figure that stuff out, both and how many things there were to figure out, right? Like our bodies are amazing. Our brains are fantastic. They know this stuff. just by looking around. And we have eyes too, right, which work into a whole other set of sensors for orienting ourselves. But it's such a wild concept to train a mechanical device to figure these things out. And then you realize that all of those things are really just to orient the drone relative to our planet Earth, which begs the question of like, well, is that the center of the universe? Is that the thing that it matters that everything else is oriented to? And if not, what is?
Right. It's a jarring thing to realize that the Earth is not the center of the universe.
Right, because we send things other places now. So we send stuff out to like orbit the moon, and all of a sudden,
Thanks, science.
It doesn't have the Earth's gravitational field anymore. It doesn't have the Earth's atmosphere to measure its altitude. It doesn't have the Earth's gravitational field to measure its direction. So things change really quickly as soon as you leave this one little environment where we run all of our experiments. A drone wouldn't fly. You couldn't fly a regular drone on the moon for almost every reason. Almost everything about my drone breaks on the moon, right?
So what do we chase in the next part of this series? Cool drones?
I think we should go
because the Mars rover is to an extent a drone.
Oh, that's a good idea.
They're utilizing all of this technology to drive a little buggy around Mars and poke at stuff.
I was thinking we should go find somewhere where they do drone racing, high-speed drone racing with VR headsets. And go try it. That looks really cool.
That's in between drone racing
right?
and
that could
VR.
be its own episode. I've wanted to try that actually because I think I would enjoy scoping that out. Not that I can fly; I can barely fly.
Somewhere then, I suppose, in our series on drones, we'll do something like that. But for now, thanks for hanging out for this one.
Yeah,
this is Zengineering Podcast. I'm Adam.
Brian. Keep it level. Ride it out. I have no idea.
Know where you are in physical space?